Alright, so I'm going to work through this example by hand. Please excuse the mess and the shaky camera because I'm having to use my phone for this. Now, as I'm reading through this, a small company makes two similar products, which all follow the same two-step process. So they're cutting and they're gluing. The time requirements in minutes for each product at each operation are given below. So this table shows you how many minutes it takes to glue product X and cut product X, and the same thing with product Y. Now, as I'm reading through the rest of this, the firm has 30 hours, I'm going to have to turn that into minutes, available in the next period for cutting, and 55 hours for gluing. Product X contributes $4.40 per unit to profit, so I'm going to have to make a profit objective function here. And Y contributes $4.50 per unit. Find the product mix that maximizes profit. So first I'm going to write my objective function, which is going to be P for profit. So P equals profit. And then my profit is going to equal $4.40 per product X plus $4.50 per product Y. All right, so that sets me up to be able to optimize this once I actually have my constraints. Now, each product, let's talk about this for a minute. We have product X, so this is going to be the number of product X. And then Y is going to equal the number of product Y. Now, I can't produce less than 0 of product X or Y, so X is going to have to be greater than or equal to 0. I could produce 0 of them, but I have to either produce 0 or more than 0. And the same thing with product Y. The number of them is going to have to be either 0 or greater than 0. Now back up to here, the cutting operation. I know how long it takes for me to cut product X, I know how long it takes for me to cut product Y, and I know how many hours I have available for cutting. So I have 30 hours available for cutting. I'm going to use that along with cutting information to write my next one. So 1.5 minutes to cut product X plus 0.8 minutes to cut product Y has to be less than or equal to the time I have available to cut, which is that 30 hours. Now, I need this in minutes because both 1.5 and 0.8 are in minutes. So if I take 30 times 60, I can turn my hours into minutes, and that's going to equal 1,800 minutes. It seems like a lot, and we'll get to how to deal with that when we get to the graph. So my time spent cutting product X plus my time spent cutting product Y has to be less than or equal to the 30 hours I have to cut, but in minutes. I'm going to do the same thing with gluing. So 0.6 minutes to glue product X plus 2.2 minutes to glue product Y has to be less than or equal to the amount of time, this time I'm going to need it again to be in minutes, it's currently in hours, for gluing. So 55 times 60 again to turn it into minutes, and that gives you 3,300 for your constraint for this one. Now these are what you're actually putting on the graph in terms of the inequalities to find your shaded region, to find your feasible region. And then it's the intersection points of that feasible region that you're using to maximize your profit.